Hey everybody, welcome back to another video. My name is Zach. I do tech and coding videos on YouTube. And today we're going to be doing Leetcode problem number 49, group anagrams. So this is a question that's really good to have under your belt for preparing for interviews. It's asked by a lot of top companies like Amazon, Microsoft, Apple, Facebook, etc. And the problem statement is very straightforward. Essentially, you're given a list of a bunch of different words, a bunch of different strings, and you want to essentially group all of them, return a list that has each word that's an anagram of each other grouped together. So in its own list. So for example, let's go through here. So EAT, that right there, and TEA, these are anagrams of each other because there's E, A, and T, and then here's E, A, and T. TAN, is this an anagram of the others? No, it's not. This is its own group because there's an N here and there's no E, and so on and so forth. So let's think about some data structures that we could use to solve this. Off the bat, we're going to want a way to associate between the anagrams, between which words and what anagram they correspond to. A good way to think about dealing with anagrams or with anagrams is to sort the string because there's two main approaches. We could either sort the string and then compare those strings. So for example here, EAT, we'd go ahead and sort it. So from the smallest lexicographical letter to the largest. So it goes E in order. So it goes A, E, T. And then here, this would also be A, E, T. We would compare those two and be like, hey, these are anagrams of each other. Another way is to go through each character, each letter in the word, and then check how many times each letter occurs. If all the A's occur the same number of times, for example, E's, all the T's occur the same number of times, they are anagrams. So an anagram is just a word that, or two words that are anagrams of each other that have the same number of letters, just arranged in a different way. So we can go ahead and use the sorting approach. So a good way to associate elements is a map, right? So we're using C++. So we can go ahead and make an unordered map right here. And we want to associate kind of the characterizing anagram, just the sorted version would be fine, with a list. So in C++, a list is called a vector, same exact thing, of these unsorted words, right? So the actual word that we care about, we want to sort it, see what the order of the letters are, and then if there's any other words, we want to go ahead and add it to that list. We can just name this MP or short for map. And then we want to write a loop to go through each element, each word that we have in our input. And there we go. We'll go ahead and loop through each one. We want to go ahead and sort it. In C++, we could copy it to a new location, so to a new string. So we'll do sorted string str equals s. So this right here, we'll do a copy, and then we can go ahead and sort it. It's a little bit weird how C++ does sorting, so you have to provide the iterable pointer. So that'll just be dot begin, oops, and str dot end, because we want to sort the whole string. So if we wanted to sort it only the characters after the second one, we do after the first character, we do +1, +2, whatever we want. But we want to sort the whole string. And then we'll go ahead and check if we're just going to go ahead and insert it. So C++ has a good kind of fallback method where if something, an element that you're inserting doesn't already exist in the map, they'll go ahead and initialize it to the default initialization. So right here, we're going to check, for example, if the sorted string already exists. If it does, we'll go ahead and add. The way you add to a list in C++ is push back. So we're going to go ahead and add the unsorted string, which is just S. And there we go. That'll build an association graph that'll map between all the words and their anagram and their sorted version. And then here we could just go ahead and reconstruct or construct our solution list. Oh, I'm typing really bad today. So we'll do, what is our return type? What are we returning? The function call that is a vector of vectors of strings, a vector of vectors of strings, and we can just name this result, right? And then we'll go through each element in our map. So this is a good way to just iterate between all the elements of the map and in MP. And a map is just association. The internal data structure is just pairs. So we could just do result dot push back. What are we doing here? We're adding to the list of result. And we're just going to add in each list of the words that we've collected that are associated. We don't care about the sorted version. All we care about are the unsorted versions grouped properly into lists. So we'll go ahead and push back lm in C++ to get the second element, because in our map, the first element of the pair is the sorted word. The second element is a list of unsorted words, which are what we care about. So we're going to go do lm.second. And then at the end, we'll just return our result. And this right here, for those unfamiliar, I'm looking at you, is returning. So someone would call this another piece of code would call group anagrams, and they just give us the anagrams, and it's like, hey, go ahead, sort them. So we're sorting them into lists, and then we're just returning all the sorted versions. So let's go ahead and submit. And perfect, it works. And thank you guys very much for watching. Go ahead, hit like, subscribe, and leave a comment. Thank you very much. Bye-bye.